Hello, future engineers. Good morning. Welcome back to EMFT, where equations are not scary, they are powerful. If you think electromagnetic field theory is tough, stay with me for the next few minutes, and I promise you, you will become your it will become your favorite subject. So today we will discuss about Gauss law. So Gauss law states that the net electric flux passing through any closed surface is equal to the total charge enclosed by that surface. Here in the figure we can see we consider a charge Q which is enclosed by a surface, nothing but Gaussian surface. So we can express this mathematically as psi is equal to surface integral of d bar dot ds is equal to Q enclosed. Here psi represents the total flux linkages from the charge, which is nothing but the total charge enclosed by the enclosed surface, nothing but Gaussian surface. Here Q enclosed is nothing but the charge enclosed by the surface, and D is electrical flux density and ds is differential surface area. So next we will prove Gauss law. We just consider any arbitrary surface which is enclosing a charge q and ds be the differential surface area through which the flux passes. The differential surface area vector is always chosen normal to the surface area, which is written as ds is equal to ds into an. We know that the electrical flux density at a distance r from a point charge is already we know d bar is equal to q by 4 pi r square into ar bar. So if we take the dot product with surface area ds on both sides, the equation becomes d bar dot ds is equal to q by 4 pi r square ar bar into ds into an. Here theta is the angle between the direction of ar and the normal to the surface an. So d bar dot ds is equal to q by 4 pi r square ar bar into ds into an, which is equal to q by 4 pi r square ar ds cos theta. Here the net flux passing through the closed surface is obtained by taking the closed surface integration on both sides. Why? Because the surface whatever we are considering is a closed surface. So if we go for application for an infinite line charge or whatever it may be, here we consider a point charge. So finally we can write surface integral of d bar dot ds is equal to surface integral of q by 4 pi r square ds bar cos theta. We can take out q by 4 pi out of integration. The remaining part in the integration is going to be surface integral of ds cos theta by r square. Here in the numerator within the integration, the quantity ds cos theta is a component of ds in radial direction, and ds cos theta by r square is the projection of ds on a spherical surface of unity radius, which represents the solid angle of the surface area ds at the point charge. So we can say the solid angle of the sphere is surface integral of ds cos theta by r square is equal to 4 pi. So ultimately or finally the equation surface integral of d bar dot ds is equal to q by 4 pi. In place of surface integral of ds cos theta by r square, nothing but the solid angle of the sphere into 4 pi, the resultant value is going to become q. So we can say the total displacement through the closed surface is surface integral of d bar dot ds is equal to finally q enclosed. Thank you.